Distances in astronomy are so large that nothing else in human experience prepares us to imagine them directly. For instance, we might imagine a picture like this as representing the planets to scale. But if you think about it for a moment, it's not fully scaled. Stop for a moment and ask yourself why. Did you think about distance? That's right. The sizes of the sun and planets are proportionate, but not the distances between them. Setting up a fully scaled model of our solar system is challenging because it's hard to choose a scale that bridges the gap between our experience and astronomical space. But let's try. A natural step might be to imagine Earth as a 12-inch globe. You may have had a chance to look at one, and compared to the real Earth, it's pretty small. The 350 miles from Los Angeles to San Francisco, which takes about an hour to fly or 6 hours to drive, is only about a half an inch. On this scale, our sun would be as tall as a 10-story building about 2 miles away from our Earth globe. Jupiter, the largest planet, would be a tiny house that might be several towns away. And Neptune, the most distant planet, would be a 4-foot beach ball. From where I live in Southern California, it would be on the beach more than an hour's drive from my home. Now our model gets a lot less useful to us because the next step we would like to take is to a star outside our solar system. On this scale, the next star would be another building-size object 3 times as far away as the moon. This is beyond our experience, so we must choose a much smaller scale. Imagine shrinking our model again so that our sun is represented by a 3-inch orange. On this scale, the Earth would be smaller than a poppy seed. Jupiter, the largest planet, could be represented by a blueberry. The distance between the sun and Earth would be about 27 feet, maybe the far side of a big classroom. And other planets would be spread out over a few blocks, perhaps the size of a high school or a small college campus like my college, Chaffey. On this preposterous scale, with our Earth represented by a speck that I can barely resolve without reading glasses, the next star could be another orange. From California, that puts the next star in Canada or Mexico or Hawaii. Beyond our solar system, we find ourselves in the Milky Way galaxy, an immense disc-shaped distribution of 100 billion stars. They range in diameter from 1/10 that of our sun to 10 solar diameters. So now it's the stars that range from bigger berries to various sizes of beach ball. Here, we're considering only main sequence stars, typical stars in their stable middle age, not the rarer exotic end stages of stellar evolution, like giants or white dwarfs or neutron stars. So on the scale we're imagining, think of stars as 100 billion berries to beach balls, typically scattered at distances of thousands of miles. The galaxy on this scale would be almost 40 million miles across, halfway from here to the sun. I think that to really get this scale, it's best actually to go outside with your poppy seed and some bits of fruit or circles of paper, if you think that's more dignified, and actually lay out a scale model of our sun and the distances, at least as far as the Earth and Jupiter. And then close your eyes and think of the stars as billions of glowing oranges, thousands to hundreds of millions of miles away. In my experience, this sits in the mind more vividly than looking at tables of numbers. So I ask every one of my astronomy classes to do it every semester. If it doesn't blow your mind, you're not paying attention.